Lesson 10.7 Electric Generators and Back EMF. A loop of wire is rotated in a magnetic field. Since the angle between the loop and the magnetic field is changing, the flux is changing. Since the flux is changing, an EMF or voltage is produced. For a conducting rod moving in a magnetic field, we had the EMF was VBL sine theta. 2 rods for each loop, so we're going to multiply it by 2, and we might have many loops of wire in here instead of just a single wire, so we'll multiply by n. Often we want it in terms of angular velocity instead of tangential velocity. So that means that theta equals our angular velocity times t. So I can put that in there. And the vertical sides turn in a circle with a radius width divided by 2. Width would be the whole width, and we're rotating around the center. And so the tangential speed of each side is r. That's a formula we had before, a long time ago. Tangential speed equals r times the angular speed. So our r was w over 2, so our tangential speed is width over 2 times the angular speed. So we can put that in. But the area is length times width, so it simplifies out to EMF is NBA angular speed sine angular speed times t. Maybe you'd want parentheses there. N is the number of loops, B is magnetic field, area, A is the area of each loop, the omega, the W looking thing is the lowercase omega, is angular velocity, which also equals 2 pi times the frequency, and T is our time in seconds. According to Lenz's law, the current will flow in one direction when the angle is increasing, and the opposite direction when the angle is decreasing. Because the current changes direction, these are called alternating current generators, and this is the most common type of electrical generator. It's what we use in the US. The big ones that use to produce power are alternating current. So let's say you made a simple generator to power a TV. The armature is attached to the rear axle of a stationary bike. That means the axle of the generator. So every time you pedal, the rear axle turns 10 times. Your TV needs RMS voltage of 110 volts to operate. The magnetic field is 0.2 Tesla. Each loop is a circle with a radius 3 centimeters, and you can comfortably pedal 3 times a second. How many loops must you have in your generator so you can watch TV while you exercise? You know, if you slow down, then the TV turns off. So it sounds like great motivation to keep going. Well, a few things. The formula had maximum volts, so we need to find our maximum volts. We have the RMS volts. RMS was our maximum divided by the square root of 2. All right, so our V RMS was 110, multiply that by the square root of 2, and our peak voltage then is about 155.6 volts. All right, that volt is the same thing as our EMF. So our peak EMF occurs when the sine of whatever our angle is, our angular velocity times t, when that equals 1, because it's times by sine of the stuff, and the maximum sine is when sine equals 1, it's the biggest value sine can be. So since we have our peak EMS, our maximum EMF, we want the maximum value for sine. So if we fill this into the formula and I let sine of the angular velocity times time equal 1, that would have been here, nice little 1. And I replace the angular velocity with the 2 pi times frequency. I can fill things in because that's the stuff I had. So that was our peak voltage. Our area, it's a circle, so it's pi r squared. Magnetic field is that. And then we have 2 pi, and then this is our frequency, because we can pedal 3 times, and the axle turns 10 times for each time we pedal. So we'll have 30 rotations a second, so 30 hertz. There's our frequency. Multiply the stuff together and divide by the volts, and you get N to be 1,460 loops. There's also something called back EMF. When a coil is turned in a magnetic field, an EMF is produced. If an electric motor is running, its coil is turning in a magnetic field, because to have a motor, we're running a current through a little loop in a magnetic field, and that causes it to turn. Well, once it's turning in that magnetic field, it's like a generator. And it will have EMF produced, or I should say induced, that is opposite the direction of the one used to make the motor go. Hence it's called back or backwards EMF. It'll reduce the voltage across the motor and cause it to draw less current. And so the back EMF is proportional to the speed. So when the motor starts, it draws the maximum current, but as it speeds up, the current decreases. That's all for today. Have a good day.